All right, today we're going to talk about volumes of pyramids and cones. A pyramid is going to come from a prism, a rectangular prism. And what ends up happening is if you took 3 pyramids, it would equal the volume of a rectangular prism. So the formula for a pyramid then is going to be 1/3 the area of the base times the height. Again, remember the area of the base times the height is the formula for a prism. Another way to say it is area of the base times the height of the prism divided by 3. Now it's important to remember, like we've seen before, that the height is going to be identified by the 90-degree angle. So in this case, the height is actually given. Now in the formula, keep in mind how many numbers we actually need to enter. The area of the base is going to be 2 numbers. So in this problem that we're presented with, the base is 8 by 8. So those are going to be the 2 numbers that we're going to multiply for the area of the base. Now the height is given, and so we're going to multiply that by 10. So our formula ends up being 8 times 10 divided by 3 because it's a pyramid. And we get a final answer of 213 feet cubed. So again, keep in mind, you need the height and you need dimensions of the base. And the height is given, the hint that the height is given is the 90-degree box. In this next example, we see we have dimensions of the base, but what we don't have is dimensions of the height. What they give us in this problem is called a slant height. And you notice in the slant height, we don't have a 90-degree box given. So we need to figure out what the height is from here to the top of the pyramid. So what we're going to do in this case is we're going to create a right triangle, and we've done this in the past many times. We're going to figure out what the height is. Now, when we do this distance right here on the bottom of our new imaginary triangle is going to be half the distance of the side that is parallel to. So this is 16, this side is 16, and it's parallel to this part of the triangle that we're using. So that distance is going to be 8. The height will be listed here, and then the slant height now is going to be our hypotenuse. So we're going to do our Pythagorean theorem. Keep in mind the slant height is our hypotenuse, and that's going to be by itself. And recall the 3 steps of Pythagorean theorem for this unit is going to be to square the numbers, to subtract, and then square root that answer. So when we subtract 64 from 289, we get 225, and then we square root and get a height of 15. So now we have the information available to enter into our equation. So the base is 16 by 16 times the height divided by 3 gives us a total answer of 1,280 meters cubed. For cones are very similar to pyramids. A cone is going to come from a cylinder, and we learned the volume of a cylinder is the area of the base, which is pi r squared, times the height. Similar to a pyramid, 3 cones would make up the same volume of its related cylinder. So in this example, we need 2 dimensions. We need a radius and we need a height. So if we're given a radius and a height, typically the height is listed from the top of the cone, the vertex of the cone, like so. So in this example, we're given the height. What we're not given is the radius, but we are given the slant height. So in this example, we have to do Pythagorean theorem again, just like we did in the last problem. So this is the radius that we're trying to find. This is the height, and this will be our hypotenuse of Pythagorean theorem. Again, the 3 steps of Pythagorean theorem are the 3 S's. We're going to square these numbers. We're going to subtract 16 from 25, and that gives us 9. And then we're going to square root that answer. So that gives us a radius of 3. So now we have enough information to be able to enter it into our volume formula. So we're going to do, this 1/3 is the same as dividing by 3. Because of the PowerPoint, it can be kind of difficult, so I just want to present this to you as 1/3, but it's the same as dividing by 3. So we have pi times the radius squared times h, and so when we plug these values in, the radius is 3, so we square it times 4, divided by 3 times pi, and we get a total answer of 12 pi. So in cones, in cylinders and spheres, we can have answers in pi, or we can have the decimal equivalent. For this particular answer, we can leave it just like this. On a test that's multiple choice, you would need to just pay attention to what the answer is, whether it's written in pi or in decimal format. All right, now in this example, they give us the radius and they give us the height. So this would be the very basic example for a cone, where the other one would be a little bit more intermediate. So this one, what we do is 1/3 pi times the radius squared times the height. So we would square this times 16, so 9 times 16 divided by 3 would give us 48, and then the pi is there. And if we want to convert that to decimal, we would multiply that by pi. All right, here's an example where a lot of students struggle is they give you the volume in the problem and they want you to find one of the other two dimensions. So they give you the radius, they want you to find the radius of the cone. So that means they have to give us the height. So in our equation, this 240 is our volume. Prior examples, we had to calculate the volume. In this example, they gave it to us. So then we have 1/3 pi r squared times the height. In this case, the height is 57. So what we're going to do in this problem is everything on the right side that's not a variable, we're going to combine into a number. So in this case, 57 divided by 3 times pi, right? And then we're going to divide both sides by that. So 57 divided by 3 is 19, and that would be 19 pi. So we're going to divide both sides by 19 pi, and when we do, we get r squared by itself. Now this number right here, we need to figure out what that actually is. And that number actually ends up being 4. It's approximately 4. So now the last step is when we have a variable squared, we have to undo that. And to undo that, we're going to do a square root. So now we found our radius for the problem. This type of problem can also be done for a pyramid or any other shape where they give you a volume and you have to find one of the other variables. And what you do is you multiply all the numbers on the one side and then divide it by the other side. In this particular example, we could also have done this by finding the height. If they had given us a radius, and to find the height, we could do that. The only difference when we find a height is we do not need to square root. Only when we find a radius in these problems with cylinders or cones do we need to square root the answer to find the radius.